It's about time I cover all these updates I've been doing to my scripts. Welcome to SETI Astro. So if you have my repository, you'll now find all my script under script SETI Astro, and that's where they're all going to be stored now. We'll just go through the scripts, and I'll do a brief update as to what's changed since my video when I introduced them. My first one is the star stretch script. Back then, I didn't have a new instance button. There wasn't the color boost. That's now all incorporated now, and we can go ahead and just run it. I think everybody's very familiar with the star stretch script. It just does what it says it's supposed to do and stretches up your stars from a linear state to a nonlinear. The next one has had some recent changes to it, and that's the narrowband to RGB star combination tool. I did have a request to be able to do dual band filter one-shot color images, so I have that in there so you don't have to do your own extracting or anything. You could go ahead and put the image in for that. There's also a green channel blend ratio. I have it just at the default that's currently in the math, but if you slide it more to the right, you'll see that the redder stars kind of get more orangey, or sliding it back to the left will make the red more prominent. It's just the blend of hydrogen to oxygen. And then as always, we have the star stretch at the bottom. So I think we're going to go ahead and load my narrowband stars. Now this is just a fake test. I actually don't have a one-shot color camera. I combined the hydrogen and oxygen stars together into an RGB image, so we could just dump it in there. And we'll go ahead and apply the star stretch as well. We'll just hit execute. It's going to go ahead and extract the data we need, create the image for us, and apply our star stretch. So there we go. Now we got our dual channel, if you will, stars from the image. Next update I want to cover is in my statistical stretch. I got rid of the number of iterations and just made an automatic convergence checkbox. So what that's going to do, if the median shifts far away from the target median during the normalization process, then it's going to recognize that and re-put the median back to the target value. So 95% of the time, that automatic convergence button is going to do nothing, as the analytic solution is very robust as is. On those particular times where you may be doing a very low stretch, and then the normalize option here really brings it fully up, then the automatic convergence will go ahead and take it down. So I have my Wolfrite 134 that I'm working on right now in oxygen. We're going to go ahead and pull up a histogram and see what's all going on and why I included this automatic convergence. Okay, I have the generalized hyperbolic stretch process open so I could have a good histogram down here. I have my statistical stretch open on my Wolfrite 134 oxygen image, and we won't normalize it at first. So I'm just going to have the target median at 0.25. We'll tell it to execute. And then we're going to go ahead and see the histogram down here change, and the median is exactly at 0.25, and we can verify that as well with statistics. And there's our median exactly at 0.25, which is what we wanted in our image, right? That's what we had the target value set to. And we can go ahead and track the view here as well. So let's open the script back up. Now we're going to go ahead and normalize the image, which is set to default turn on. Again, what's that going to do is fill out our entire image to cover the full range from 0 to 1. So we're leaving no dynamic range on the table. We'll tell it to execute. And now we can see that there was a shift. The median is 0.266. So what it did is it took the highest point and slide it all the way up to 1. And what that does is it has a tendency to slide the whole graph a little bit to the right. So now we'll go ahead and run it with automatic convergence on. We'll turn on automatic convergence and hit execute. Now it's going to run through the script. It's going to realize that the stretch was a little too far, and it's going to redo an extra portion of it to go ahead and place our median exactly back at 0.25. I set the tolerance such that it won't be all zeros, but it gets you where you need to go. So that's what automatic convergence does. It ensures that whatever target median you selected is what it's going to actually achieve. There have also been some changes to the continuum subtraction utility. It's still set up to have a starry or starless image. You can go ahead and select your emission line group and your continuum groups. But now there's an option to either apply noise reduction if you own Star Exterminator or have Graxpert downloaded. And that's going to apply noise reduction immediately after the subtraction itself, when everything's still in a linear state prior to stretching. If you own Noise Exterminator, you just click Noise Exterminator. If you have Graxpert Denoise, you can go ahead and select that. It does require the Graxpert process to have already been downloaded. So if you don't have that and try to execute, you're going to go ahead and get a warning with the website where you could actually go ahead and download that. And then you can select your AI model. There is a new AI 3 that has came out, and it is unique. Definitely look up videos on YouTube about AI 3 about Graxpert, but it does allow you to switch between those two. And then there's also an option to do an output the linear image only. So that's going to output the image right after subtraction and right after any noise reduction that you may have selected. It won't do any stretching. It's going to be in a completely linear state immediately after the subtraction. So let's go ahead and run it. We'll apply the noise reduction with Noise Exterminator. We'll hit execute. It's going to go ahead and run through its normal process on finding the background, color calibrating it with the stars, doing the linear subtraction, and now it's going to jump into Noise Exterminator, run that, and now do the stretch. And there we go. A beautiful, noise-free, continuum subtracted image just ready to be integrated back into your image. The last update that just came out today is in the Find Background script. With version 1, it ran on the whole image. So I have a linear image here. If we go ahead and just run STF, you can see that there's a big pedestal on the blue and the green. That's normal for a lot of these RGB images. We can run an unlinked stretch, and there's a big dark nebula here, and pretty much the entire thing is covered in stars. So if we just go ahead and naively run our Find Background as is on the default settings on fast search, it's going to go ahead and it's going to just find that dark spot in the dark nebula. And sure enough, it found it in the dark nebula. It's the only dark patch in the entire image. That may or may not be good depending on your image, right? Some dark nebula have a very strong color cast to them, and you wouldn't want it in there. Other dark nebula are very neutral, and that may be where the background actually is. But what we incorporated now is a means of dealing with these situations. So it may be a dark nebula, it may be a dust mote that's darker than everything else that you don't want it searching in. It may be you weren't able to remove the gradient fully, and all those things can lead the Find Background astray as it's looking for those dark areas. So there's now a user-defined search area, and it'll pull up a preview. And now you can shift click and drag a rectangle, and that's the area it's going to search now. So it's going to totally avoid everything else in the image. Since the image is so much smaller, you're going to want to either reduce the number of starting points, right? This is maybe a quarter of the entire image, or just do a slow search, right? It's a much smaller image. The slow search is already pretty fast now because of it. I'm just going to reduce the number of starting points to 10 and tell it to search. Okay, and it's done, and we can go ahead and close the script. And now here's our background. This is where it found it down here. You're not going to be able to avoid stars in this particular image, but it's a great example of utilizing the new user-defined search area within Find Background in order to avoid areas that you don't want the algorithm actually searching in. Always, I have updated my website, SteadyAstro.com, under the PixInsight scripts. For all these new versions, it has the URL for the repository and the standalone versions. We got the star stretch, narrowband to RGB star combination, statistical stretch, find background, and the continuum subtraction scripts. I hope you guys have found these tools very helpful. And as we build our community out, I am open for suggestions and continuously changing these scripts. I have also started a membership on YouTube, so if you want to become a member, be sure to click that. I'll be putting out member-only content and allowing people to use beta versions of scripts as I'm making them, and other fun things. I hope you liked the video. Comment, like, subscribe, and become a member.